Hi everyone, I'm Ralph and I like music and Blinkenlights. The Yamaha DX7 digital synthesizer is notoriously hard to create voices for.
I mean, these are the things. I mean, the DX synthesis method, while incredibly powerful, has always struggled to capture the imagination of the user because it's frankly a nightmare to program because it's so unfamiliar.
Well, I can't argue with that, can I? Still, despite the difficulty of creating original sounds on the Yamaha DX7, I think DX7 owners should put some effort to it. If, however, you simply can't be bothered, there's a ton of excellent voice banks for the DX7 available on the Intertubes. And you don't even have to hunt and gather. On the website of Bobby Blues, you can find and download a zipped collection of all the voices that he could find over the years on the internet. It's a 25 megabytes download. The collection contains over 12,500 files in nearly 500 folders. Just to be sure, that's more than 12,000 sound banks with possibly 32 voices each for a total of nearly 400,000 voices. Surely there's something in there for everyone. Now, if you start auditioning these voices, you might find that a lot of them sound very much alike. One reason for that is, I believe, intrinsic to the DX7. FM synthesis is very well suited to mimic certain classes of timbres, in particular brass sounds, electric pianos, chromatic percussion sounds, and all sorts of metallic twangs like bells and tines. The other reason, however, is far more banal. The voices sound alike because they are the same. In a collection of hundreds of thousands of voices, you're almost guaranteed to find a few duplicates. Bobby Blues even indicates on his website that he didn't tidy up the collection and that you have to expect to find several duplicates. Well, that's exactly what we're going to do. So we're really distilling the essence of Bobby Blues, all the web collection, for the benefit of the DX7 community. Okay, so let's see what's in the 25 megabyte collection, shall we? Here's a skeleton program with a simple user interface that allows us to identify duplicates in the library. You'll find the user interface a bit awkward because like this, it's not really suitable for anything other than finding duplicates. It's not a librarian by any stretch. So how are we going to identify duplicates in the collection? To identify duplicate voices, you technically have to compare each and every voice to every other one to see if they are equal. Of course, you don't literally do that. What you do instead is to build a data structure of voices where you guarantee by construction that there aren't any duplicates in there. For every new voice, you check if it's already stored. If it isn't, you add it. If it is, you've just found a duplicate, so you make a note of that fact. In any case, you store with the voice which bank contained it at which slot. This way you can later list all banks that contain that particular voice. I consider two voices to be different if any of the parameter values are different, even if the voices sound alike or even completely the same. We'll ignore the name, however, because the voice name doesn't contribute to the timbre of the voice. Why that's relevant becomes clear in a minute. Alright then, rock and roll! Let's go ahead and run the bloody thing. Here's the user interface again. In the left hand pane, at Tree View, we are going to see the complete list of sound banks with all the voices underneath. In the right hand pane, we're going to see all duplicates of the voice selected in the left pane. The bank that contains the voice, the index or slot, perhaps I should have called this slot and not index, in which a duplicate voice is stored. The status bar indicates the number of copies of the chosen voice. First we need to load all banks into memory, all of them. Initially it'll take a while to load all the banks from disk. On subsequent runs we can expect the disk caches to be filled and loading should proceed a lot faster. Bang! Done! 12,500 banks processed. The pop-up window shows some statistics. Out of the 12,500 banks, we were able to load 11,164. We had 1,336 errors. These are banks that had the wrong structure. I'll check some other time why they didn't process. So we have 347,193 voices in total, with 29,868 distinct voices. That's less than 1 in 10 voices in the whole collection. More than 9 in 10 voices are copies of other voices. 2,120 unique voices. These are voices that appear exactly once in the whole collection. All other voices appear 2 or more times. Unique voices will show in orange in the list. Init and null voices. These are the result of banks that are not full. That is, banks that contain fewer than 32 defined voices and therefore contain empty slots. There's 2 possible choices to indicate an empty slot. One is using an init voice. An init voice is what you get if you choose the voice init function on your DX7. Also, if you format a RAM cartridge, the synthesizer will fill it with init voices. The null voices are, I suspect, from software librarians that simply fill empty slots with all zeros. I singled both of them out so they don't disrupt the statistics. So here's the alphabetically sorted list of all 11,164 banks. Ignore for the time being the blue color on some of the banks on the left. You can immediately see that there are multiple copies of the bank on top, the $M3 bank, and more so if we scroll downward. Let's see the voices underneath. You can immediately see that most voices appear several times in the collection. Piano clav 98 times. Incidentally, notice also that the same voice is stored under various names in the different libraries. That's why we ignore the names when comparing voices. Pluck plus 151 times, Rhodes EQD 167 times. JC Ensemble A. This one's a unique voice. It appears only in this one bank in the whole collection. And on and on. Okay, that takes care of duplicate voices. It appears that the same voices are quite liberally stored under various names in various banks. But are there also wholesale copies of complete banks in those collections? There's only one way to find out. To identify duplicate banks, in our case this means banks that contain the same voices irrespective of order or voice names, we can essentially do the same we did for the voices. That is, build a data structure holding only distinct banks and making notes of duplicates in the process. These are listed under distinct banks in the statistics. That's 3,284 distinct banks. These are original banks. All other banks are copies of those 3,284. As you can see in the left-hand pane, most banks appear 2 or more times in the collection. These are in blue. The black and orange ones appear only once. I already said that orange voices are unique voices. Orange banks contained only unique voices, so these are unique banks. Now what does all this mean? Well, it means that you could delete all but those 3284 banks from the collection and still have one copy of every original bank. Again, ignoring name and order of voices in these banks. So the 11,164 banks we started with can be reduced to these 3,284 original banks. But obviously there's still a lot of voice sharing between them. This naturally leads to a new question. If you didn't care about those original banks, what is the minimum number of banks required to contain all the voices? This is an instance of the so-called set cover problem, where you want to find the minimum number of subsets that contain all elements of a set, in our case elements being voices and subsets being banks. While the set cover problem has a definite answer, it is spectacularly hard to find. You have to effectively check every possible combination of banks to see which combination contains the fewest banks while still containing all the distinct voices. There is, however, a way of approximating the real result using a greedy algorithm. You keep adding those banks to the solution that contain the largest number of not yet included voices. For every bank you add, you enumerate the voices that it contains and delete each of them from every other bank that also contains it. If the last voice in a bank has been deleted, the bank is redundant and can be deleted as well, because every voice in it has already been added to the solution. In our case, we begin by adding all those banks to the solution that contain unique voices. Because unique voices appear in only one bank, or they wouldn't be unique, and we don't rearrange banks, these banks must be in the solution. After that, we proceed as stated above by adding banks with the largest number of not yet included voices until none is left. By fine-tuning the process using a simple heuristic, I was able to get a number of 1,760 banks. This is the minimum set. So you could delete all but these 1,760 banks out of the collection of 11,164 and still have all the voices. If we unfold the bank, we can see which voices it contributed to the final set. They're shown in dark red. You can see which banks were added last. Only 1 or 2 voices were added. There's obviously still some duplication, but at the very least you can see which voices you need to consider when auditioning the collection. Just keep with the dark red or orange ones and you'll be fine. Of course, there's still more than 29,000 voices to audition, which should keep you occupied for a while. But at least you don't have to waste any time on duplicates. Alright, that's all for now. I hope you liked this video, and if you did, please give it a thumbs up. In the meantime, thanks for watching and don't forget to share and subscribe for more music and Blinkenlights. Tschüss zusammen!